Welcome to a brand new concept under graphs and transformations. This is the third part of this whole chapter on graphs and transformation, where we're going to be really zooming in into the whole idea of transformation of graphs. Right, so I want to start off this video by explaining what transformation of graphs is and the various ways that we can transform a graph. Okay, so transformation of graphs is simply just changing one original graph, so our original existing graph, into another new graph, right? That's the whole idea of what transforming is, right? If you think a bit about it in layman terms. Now, there are typically three ways that we transform a graph. The first way is by translation. Okay, the second way is by scaling. And then the third way is by reflection. So in very layman English, translation just means move left, right, up, or down. That means you got a graph. So imagine my pen over here is a graph. I move left, right, up, down. Like I'm literally just shifting it. So that is one way of changing a graph, right? What scaling means is just pulling the graph vertically or horizontally. So if translation is moving a graph physically, scaling is making sure that the graph stays in place, and from here I stretch it. So if let's say I originally have a circle here, right? I'm just gonna demonstrate to you. Originally I have a circle here. If I move it left and right, this is called translation. I'm just moving it. But if I pull it out like that, right? I'm scaling it, right? Because I am pulling the graph, right? I'm either pulling upwards, pulling upwards or sideways, right? Or sideways like that, right? You get the point. So then reflection will be just your inverting a graph, right? Inverting it vertically or horizontally. So that's basically the whole idea of it. So let's say I have a graph like that, right? And then let's say I'm not able to show it here, but if I invert it, then it will look like that, right? I'm just like flipping it around. So that's the whole idea behind it. So the first part we're going to be focusing on is your translation. And translation, as you can see, there are two kinds: your horizontal movement, your lateral movement, and your vertical movement, up down. So let's say I start off with a graph, right? Let's say y equal to fx over here. And let's say my graph is originally, okay, I'm just going to put a dot here, y, x over here. Okay. And then let's say I have a graph that goes like that. Okay, so let's just put this as y equals to fx over here. There are four ways that I can translate this graph. Okay, so this video will be pretty long, but make sure you take down the notes, especially the way I present the concepts. So translation, there's two types, right? You can either translate upwards or downwards, which is your vertical movement, or you can translate left or right, which is your horizontal movement. So if you're going to translate it up and down, then this one, there would be a way that we do it. Okay, so for instance, let's say my goal is to shift the graph up by 1 unit. So if I want to shift this graph up by 1 unit, and for instance, make it into a graph that's like that, right? If I want to shift it up by 1 unit, every single y value has to up by 1, right? So if we compare here to here, this y value has to up by 1, this y value has to be up by 1, this y value has to be up by 1, this y value has to be up by 1, so on and so forth, right? And then now the y-intercept here will be 1. So if I want every single point to shift up by 1, then what that would require me to do would be to make the graph y equal to fx, right? I need to transform it to y equals to fx plus 1, right? I need to transform it so that every single fx value it plus 1 and it goes up. So this is the first kind. I'm just going to write it here, where you translate it upwards, right? And then this is y equals to fx plus 1. So if I'm going to translate it this way, then what change must happen? So I want you to remember a golden rule over here, right? In transformation, any kind of transformations, only x and y can be subjected to changes. And what that means is that if I want to add a plus 1 over here, I can only replace y with something new, or I can only replace x with something new. I cannot do anything else. So for this case over here, what I will do is I will replace, or what I'm doing in the background, right, is that I am replacing y with y minus 1. Because when I replace y with y minus 1, it becomes y minus 1 equals to fx, right? And then when I shift the 1 over, it becomes y equals to fx plus 1, which is what we want at the end. So we can only replace y or replace x with something new. So if I'm going to replace y with y minus 1, then what is the outcome of it? So the outcome would be I translate y equals to fx by 1 unit in the positive y direction. So this whole presentation over here is your classic presentation for any transformation. So if I were to generalize it, right, a very classic way of writing your working, which I'll show you later on, would be y equals to fx, or rather your y equals to your original graph, and then you draw an arrow, and then you'll say y equals to your new graph, whatever change that you make to it. On top here, you will write the thing that you replace. So you either replace x or y with something, and then below you will write down the effect of that change. So below you'll either write like translate or scale, all right, or reflect, So this over here is the classic way of presenting your working. Okay, so we must always follow this classic presentation. Okay, so this is one way. If I want to shift it up, then I'll replace y with y minus 1, right, for instance. Okay, I'm just going to color this whole thing. Okay, and then I am going to shift it here. Okay, good, let's carry on. So that's one case. But then let's say what happens if I want to shift it down. So what I want to do is I want to go from y equals to fx. Then now, instead, I want to make it y equals to fx minus 1, right? What happens if I want to just shift it down now? So I draw this line under here, right? And then now this is y equals to fx minus 1, whereby here is minus 1. So we can see that every single value drops down by 1 now, right? So this way, we will actually replace y with y plus 1. And then the change that happens is that we translate y equals to fx by 1 unit in the negative y direction, right? So translate the graph by how many units. So this one is something that you need to contextualize in what direction, positive or negative. So this is positive, this is negative, this is positive, this is negative, and is it in the x or the y direction? Okay, so that is that. Now, this, so far all we have been talking about is just up and down, right? Well, if we want to translate it laterally, then that would be the third case. Third case would be, let's say I translate it to the side. So now what happens is, if I want to now shift it to the side here, so it means that, let's say I copy this, and then let's say I paste it, okay? So let's say originally my graph is here, right? Now what happens if I want to just shift it to the side now, right? Okay, the constraint is that all of these lines look the same. But let's say what happens if I want to just shift it to the side now. So if I want to shift it to the left, that means every single x value will minus 1, correct? So originally, over here is x equals to 0. And then now, this x equals to 0 becomes x equals to negative 1, right? When I shift it to the left, every single x value drops by 1. So what change must I apply to this so that this graph can shift to the left? That is where I will replace x with x plus 1. Okay, so the counterintuitive thing about shifting laterally is that when you shift to the left, when you want to minus the value, you plus it instead. And let me show you why. Because this, okay, wait, let me just write it here first. So this one would be y equals to f, or rather y equals to f x plus 1. Okay, the reason is very simple. This one is the old value, this one is the new value, right? If I want to shift everything to the left, so for instance, the old value is x equals to 0, right? And then the new value is now x equals to negative 1. When I shift it to the left, you can see that the old value equals to the new value plus 1, right? Because you see that here is, because you see that here is 0, and then now here is minus 1, right? Because I shifted to the left. So in order for them to equate to each other, the O must be the new plus 1, because when I plus 1 here, then it makes it 0. And that's why here is plus 1, because when I translate it this way, my x value, my OX value, will now be this value plus 1. Okay, so it's the reverse, as I illustrated it over here. So, you just got to get used to this. and you'll be well on your way to solving all the questions associated with this. So the description is the same. That would be translate y equals to fx by 1 unit in the negative, but this time would be x direction. Okay, so that is basically it for that. So this is number 3, right? I'm just gonna write it over here as y equals to f x plus 1. And then of course, if you think about it, if you want to shift forward to the right, then it'll be -1, right? The same logic applies. So now let's say if I want to shift it forward here, let me just draw this properly, right? Let's say I want to shift it forward here now. This will be y equals to f x minus 1. So the fourth case would be y equals to fx, which is my original graph, right? I change it to y equals to f x minus 1. And now the change would be replace x with x minus 1 because I want to translate the graph by 1 unit in the positive x direction. That's what I'm trying to do over here. Okay, so it does not apply to just straight lines. It applies to any graph, basically, right? As you can see over here later on when we do the question, you will see that it actually applies to many graphs. So yeah, that's it for this section. So this is a very long video, but I've just explained to you what transformation is all about, right? The different kinds of transformation that can happen to a graph, as well as specifically when we talk about translation, what are the 4 different ways you can translate a graph? Up, down, left, right, in short, and the respective ways to actually present your working. So this one, crucial, very crucial. Okay, you need to present your working this way. Okay, if not, now we will tackle a question over here, and you can see that I'm going to be using this example over here to show you how to actually apply the working above in this question, and then below you will try the question out for yourself. Okay, so let's look at this question over here. The diagram shows the graphs y equals to x squared and y plus 5 and y equals to x squared minus 3. So we can observe from here directly that this graph is just a translation of this graph. This graph is just a translation of this graph as well, right? So our original graph is y equals to x squared. And when we translate this graph to y equals to x squared plus 5 over here, what did we do? We actually replace y with y minus 5, right? Because when we do y replace with y minus 5, I get this. And then when I bring the minus 5 over to the other side, I get this. So if I'm replacing it with y minus 5, and I go from x squared to x squared plus 5, you can see that the original graph x squared is here, and then the final graph is here, right? So we actually shift up everything by 5 units. So the way that we actually write our answer would be, and also contextualize to the question, right? They say, how is it related to the original graph? So we will say y equals to x squared plus 5 is obtained, just contextualize the explanation a little bit, by translating y equals to x squared, right, the original graph, by 5 units. So by how many units again? In the positive y direction. And that would be the answer. So this portion over here is actually the answer. Okay, and then for the next example, it's exactly the same thing. So I go with y equals to x squared again. And then over here, it becomes y equals to x squared minus 3. So you can see over here, I replace y with y plus 3, right? Because when I shift the 3 over to the other side, then it becomes a minus. So you can see that original graph is here. What I did is that I shift it down by 3 units. So the whole working, or rather the blue portion, is the same explanation, but I just contextualize it, right? Y equals to x squared minus 3 is obtained by translating y equals to x squared by 3 units in the negative y direction. And that's the final answer over there. Okay, so it's just follow the same way that I teach you how to present here, and you'll be alright. So that's about it. Okay, so now feel free to come and pause this question and try it out for yourself. And when you're ready, come back and unpause this to see the solution. Alright, so let's break down this. So it's like pretty much the same question as before, right? We start off with this x squared, and then we just need to ask ourselves, what's the difference between this and y equals to x plus 3 squared, for instance, right? We know that we replace x with x plus 3. So if you recall what I said earlier, this sign is actually the opposite. Like the idea is opposite to what you expect, right? If you plus, you're actually moving backwards. As you can see over here, here is the original graph, and then here's the plus graph, right? We actually shift backwards. So the standard explanation for this would be translate by 3 units in the negative x direction. Oops, let me just contextualize it. So y equals to x plus 3 square is obtained by translating y equals to x square by 3 units in the negative x direction, right? And that would be good enough. Now the next one would be the one at the bottom. So here you have y equals to x minus 3 squared, and then you can see that obviously the change is you are replacing x with x minus 3. So the whole idea behind this again is very contradictory, because now when you minus, you are going forward, right? You can see over here you are actually going forward. So again, the explanation is different. Y equals to x minus 3 squared is obtained by translating y equals to x squared by 3 units in the positive x direction, right? And that will be all for this question over here. So yeah, that's basically for this whole portion. Actually, this part of the chapter is just a lot of writing, but more or less it's like that. Can't really. Okay, so if you got any questions, feel free to reach out. Otherwise, that'll be it, and I'll see you in the next video.